Hi, I'm Fred Worrell. I'm Professor of Environmental Chemistry in the Department of Earth Sciences, and I'm also Director of the Environmental Geoscience degree programme. Environmental Geosciences is the part of the Earth Sciences that actually covers how we interact between the geosphere and our environment, or how the environment interacts with us, of course, from natural hazards to resources to managing the implications of both. Environmental geosciences will only increase in importance as we have a more crowded planet, more demanding humans on those planets for human resources. We need to actually get those resources, we need to manage finite resources, and we need to make sure that we're not impacting on those in a way such that then they would actually limit our own sustainability and our own existence. So in the Environmental Geosciences programme, you'll cover a range of subjects and topics. So this will start with subjects like hydrology and hydrogeology, so the water cycle, how do we manage those resources, how do we get that resource, how do we stop it being contaminated, how do we clean it up. It could include subjects like soil science, in climatology, as well as mineral and energy resources. So in first year, you'll cover water, climate, mineral and energy resources. In second year, fieldwork, although field trips exist in all years for the Environmental Geosciences. In the second year, the fieldwork will particularly help develop skills for the dissertation, which is typically then you take at the end of the second year going into the third year. In third year then, you carry on with that dissertation, but also you'll cover such subjects as environmental chemistry, environmental management, so that'll include subjects such as impact assessment, audit, water management. The dissertation itself can be field-based, it can be lab-based, or it can be data-based. In fact, most students do a mixture of one or two or even three of those sorts of approaches, so they get the range of skills between field, lab and data. Yeah, so graduates from our Environmental Geosciences programme have a very high rate of employment. And indeed, at the moment, we're sending graduates to such companies as Northumbrian Water, Yorkshire Water, Natural England, Environment Agency, large engineering consultancies like Atkins. So it's quite a diverse range. Around about 50% at least of all Earth Sciences graduates end up in the environment industries. And so therefore, if you've got an environmental geoscience degree, you're even better placed to take up those sorts of job opportunities. The reasons for coming to Durham to do environmental geosciences are multiple. First of all, you get to study in Durham. You can see the sort of place behind me. It's a small collegiate town. We equally within the department, we actually demonstrate both very high satisfaction amongst our graduates in the national surveys. We demonstrate very high employability near the top of this university in terms of employment rates. But equally then we're looking to develop students that are actually going to go out into jobs that will begin to make that difference for the world. And in the department we're expanding the programme through new hires, new programmes, new courses. So it is very much a dynamic part of this university and indeed of the department.
Hi, I'm Jeroen van Hunnen. I'm a professor in computational geoscience in the Department of Earth Sciences at Durham. My research involves building computer models of the deep Earth, the dynamics of the deep Earth. Geophysics is incredibly important. It's a very quantitative subject that we use to investigate complex processes. It helps us to understand and predict natural hazards, such as volcanic eruptions, or detect resources, such as drinking water, or how to live sustainably on this planet. Geophysicists use large computations and complex technologies, such as machine learning and artificial intelligence, to solve the Earth problems. The Earth is complicated, and geophysics helps us understand it. The Geophysics with Geology course in Durham is designed to give students a holistic understanding of how to use physics to explore the workings of the Earth. In the first year you gain a broad understanding of how the Earth works, what it's made of, and what tools we use to understand it. In the second year you get training in the field in how to use geophysical equipment such as seismometers to image the subsurface of the Earth. You learn how to build computer models to simulate Earth processes and use remote sensing techniques to gather data and to process and to analyze the data. In the third year you will specialize into topics such as hazardous geophysical flows, or the deep structure of the Earth, or how the Earth deforms. And you will also complete a research dissertation which might involve geophysical fieldwork, or data analysis, or computational modeling. Geophysicists are in high demand in our society and in industry. Our graduates have some of the highest employability rates at the university and go on into careers such as resource exploration or renewable energy or environmental management. But their quantitative skills also allow them to get careers into construction and engineering or finance or insurance. Some go on to study at master's or PhD level, and some go into teaching. Durham has a great pedigree in geophysics stretching back more than half a century. We place your academic journey at the center of what we do and offer a broad and diverse curriculum taught by world experts to set you up for a rewarding and exciting career.
Hi everyone, my name's Rich Brown. I'm a volcanologist and I'm the Director of Admissions for the Department of Earth Sciences. Geology as a subject is really critical for the future. There are more people than ever on the planet, and as we transition towards a greener future, that new technology, that green technology, will require vast amounts of metals and rare earth elements, and these need to be sourced and extracted by geologists in a sustainable manner so that we can preserve the planet for future generations. Additionally, geology has provided critical insights into past climates on the planet, and this provides vital information for understanding what the future might look like as the climate changes. Our geology degree is designed to provide you with a fundamental understanding of how the Earth works, while also giving students the flexibility to pursue their own interests. In the first year, you'll understand how the Earth works, its deep history, and what it is made of. You'll also learn how to extract data in the field and how to apply quantitative methods to solve Earth problems. You'll learn how to interpret and analyse geospatial data using the latest software. In the second year, you'll develop your geological skills in the lab, in the class, and in the field. You can explore how the Earth's crust deforms, how life evolved on Earth, or how magmas are generated. Learn how the climate has changed in the past and how it might change in the future. In the third year, you have a lot of choice to delve deep into topics that interest you. These might be volcanology, climate science, or global tectonics. You'll also undertake a mapping dissertation, and this is where you go out into the field and you create a geological map of somewhere in the world and write it up into a report. It's your chance to write a little bit of Earth's history. If fieldwork isn't possible, come and talk to us, and we can design mapping projects using satellite data, for example. Our geology graduates have a really great employment record, and they go on to find careers within environmental management, within the geoenergy sector, within natural resource exploration, and as engineering geologists within the construction industry. A portion go on to further study at master's or PhD level. Many of these careers offer an opportunity to really make a difference to society and to the future. But a geology degree also equips you with a unique range of transferable skills, such as problem solving, critical thinking, dealing with uncertainty, and synthesizing diverse data sets. And this lines you up for a wide range of careers outside of the geoscience sector. Durham's been home to geological excellence for over 100 years now, and we really pride ourselves on the quality of our teaching and our research. And through studying with us, you will be learning at the cutting edge of human knowledge. And you'll develop a broad understanding of how the Earth works and the problems that face us on the planet now and in the future. And you'll be doing all this within an open and friendly community that is dedicated to your academic journey.